What is hybrid quantum computing? Imagine trying to solve the world's hardest puzzle. A normal computer is incredibly fast at following precise instructions, performing billions of calculations every second. But some problems, such as designing new medicines, optimizing global shipping routes, or simulating complex molecules, are so difficult that even today's most powerful supercomputers can take years or even longer to solve. That's where hybrid quantum computing comes in. Instead of replacing traditional computers, hybrid quantum computing combines the strengths of classical computers and quantum computers, allowing each to handle the parts of a problem they solve best. Why not use only a quantum computer? Despite the excitement around quantum computing, today's quantum computers are still in their early stages. They excel at certain highly specialized calculations but are not efficient at everyday tasks like running operating systems, managing memory, displaying graphics, or processing large amounts of conventional data. Classical computers, on the other hand, are incredibly reliable and efficient for those jobs. Rather than asking one machine to do everything, hybrid computing creates a partnership. Think of it like a Formula One race team. The driver races the car at incredible speeds, but the engineers constantly analyze data, adjust strategy, monitor tire wear, and determine when to make pit stops. Neither could win alone. Hybrid quantum computing works the same way. How does it work? A hybrid system constantly passes information back and forth between two computers. First, the classical computer analyzes the problem and determines which parts might benefit from quantum processing. Next, it sends those specific calculations to the quantum computer. The quantum computer performs calculations using qubits, taking advantage of quantum properties such as superposition and entanglement. Once finished, the results are returned to the classical computer, which evaluates the answer, adjusts the next calculation, and sends another task back to the quantum processor. This loop repeats hundreds or even thousands of times until the best solution is found. One of the best-known hybrid algorithms is called the variational quantum eigensolver, or VQE. Imagine scientists trying to discover a new medicine. To do that, they must understand how molecules behave at the atomic level. A classical computer proposes a possible molecular arrangement. The quantum computer estimates its energy, something quantum systems can model more naturally. The result goes back to the classical computer, which adjusts the molecule slightly and asks the quantum computer to evaluate it again. This cycle continues until researchers identify the most stable molecular structure. Instead of each computer trying to solve the entire problem, each contributes its own strengths. Why is this important? Many experts believe hybrid computing will dominate the first generation of practical quantum applications. Quantum computers are expected to become specialized accelerators, much like GPUs, transformed artificial intelligence. Instead of replacing CPUs, GPUs work alongside them to perform tasks they handle exceptionally well. Quantum processors are expected to follow the same path. Future data centers may contain CPUs, GPUs, and quantum processing units, or QPUs, all working together on the same workload. Where could hybrid quantum computing be used? Researchers believe hybrid systems could revolutionize industries that depend on solving incredibly complex problems. Potential applications include discovering new drugs and medical treatments, designing stronger and lighter materials, optimizing airline routes and supply chains, improving financial portfolio optimization, accelerating artificial intelligence, managing electrical power grids more efficiently, simulating chemical reactions that are impossible for classical computers alone. Is this the future of computing? Many researchers think so. Rather than replacing today's computers, quantum systems are expected to become powerful coprocessors that handle only the parts of a problem where quantum mechanics offers an advantage. From the user's perspective, this may eventually become invisible. You might submit a problem to the cloud without ever knowing whether a CPU, GPU, or quantum processor solved each part of it. The system will automatically choose the best tool for every task. Hybrid quantum computing is not about choosing between classical and quantum computers. It's about combining them. Classical computers provide speed, stability, and control. Quantum computers tackle highly specialized calculations beyond the reach of conventional machines. Working together, they can solve problems that neither could efficiently solve alone.